Hello everyone, welcome back to my channel Step by Step. Meet my new friend.
Hi, my name is Gullu.
Gullu is an engineer and he told me he saw my previous video about basics of steel structures. So let's see what Gullu learned from that previous video.
Learned about the various types of steel sections and its physical properties, especially for the steel plate.
Correct. And today we are going to see how to use these properties to select a perfect member. Look, who is here? He is a Darik. I saw him, he recently bought a new car. But what he wants?
I want to building a car shed of 4 mat width, 6 meter length, and 3 meter height. Can you design steel structure for that?
Yes, I can design. I am a contractor, but it will cost you around 60,000. If it's okay for you, then I can start work from tomorrow.
I can also design, and I will let you know the best price by tomorrow.
Now Gullu wants this opportunity and he wants to give a better offer than the contractor. Gullu knows one thing, that contractor only going to use that steel members which he already has in stock. So Gullu wants to do a basic analysis about this car shed and he wants to give a good offer. Let's see how much offer Gullu can make.
After the analysis, I can make a car shed for you in just 30,000.
Wow, that's great. Gullu gave an offer of 30,000 while contractor gave an offer of 60,000. So Gullu got this opportunity. Gullu told me how he did that. Let's see what he did. Since Gullu saw my previous video, so he is aware about what are all the different sections available in the market and their physical properties also available. But he don't know how to use the physical properties and come up with the perfect beam members. So he searched in YouTube how to select a perfect beam member step by step. And he found this video on YouTube. Then he put the subscribe button and hit the bell icon and saw the whole video. And let's see what he learned. Since Gullu knows the basics of Staad Pro, so he tried to model the car shed of the required dimension, that is 4 meter width, 6 meter length and 3 meter height. Then he added dead load as a self weight of the structure and live load of 3 kN per meter square. And after adding load combination as per the IS code, he gave a perform analysis for this very small structure. Then he took out the beam results from the Staad and copied to the Excel sheet. He got to know that majorly 3 kinds of forces is coming on this structure and he has to select a member which can bear all these forces sufficiently. Here, Fx represents the axial force and maximum axial force coming in this structure is 30 kN. Fy denotes shear force and maximum shear force is coming around 28 kN. Mz is the bending moment about the major axis and maximum bending moment is coming around 15 kN. First, he checked the bending strength. How much bending strength is required to resist 15 kN? That is how much section modulus is required. Gullu knows the basics bending equation. So here m by I is equal to f by y. So to find the section modulus is I by y. If we shift I in the right side, then z is the section modulus that required is equal to m by fy. Here fy is the grade of steel and let us consider it as a 350 Newton per meter square and value of n is 15 kilonewton meter. After solving, z required is coming around 43 centimeter cube. Now Gullu took out the Indian steel table and he searched for the member whose section modulus is greater than 43 centimeter cube. He found that section modulus of ISJB 175 and 200 is greater than 43 centimeter cube. Since he wanted to go with the safer side, he selected ISJB 200. So ISJB 200 has enough section modulus to resist 15 kN meter bending strength in the major axis. Now he wants to check that this member is sufficiently passing in shear and axial force also. So he gave a basic calculation for axial force and shear force. So the axial strength of this member will be gross area of the section into the yielding strength divided by some factor. And from this steel table, its gross area is 12.64 centimeter square. So 12.64 into the yielding strength divided by some factor. He found that it is around 400 kilonewton. It can sufficiently take 30 kilonewton axial force. And this axial force is in tension, so there is no issue at all. And to calculate the shear capacity of the member, he did the calculation that V is equal to AV into Fi divided by root 3. That is the basic calculation to find the shear force capacity. And to resist shear force, we used to take area of web of the I section. Why? That I will tell you later. So to find the area, we will take the depth of the section into the thickness of the web. And the capacity of this section in shear is coming around 125 kilonewton. So this section is very safe in shear, axial and bending capacity. So he can use this section in the car shed. Now let's check what is the approximate cost of the material in the car shed. So from the steel table we'll get to know what is the weight of this ISJB 200. It is 9.9 kg per meter. And what is the total length required for this steel member in the car shed? It is around 42 meters. So the total weight is coming around 416 kg. And the cost of 1 kg of steel will be around 50 to 60 rupees per kg. And that let us take roughly as a 50 rupees per kg. So the total cost of material will be around 20,800. And Gullu gets to know that contractor is using ISMB 200. Let's check what is the weight of this member. So in the Indian steel table, the weight of the member is 25.4 kg per meter. Hence, the total cost of the material will be around 42 into 25.4, that is 53,340. So the contractor quoted around 60,000 after considering his own charges of 6,000 over that. That is why Gullu quoted around 30,000 so that he can take his own charge of 9,000 from it. So Gullu is a very smart engineer. So in this way, Gullu gets to know that how to select the perfect structural members by using the member forces. So guys, if you think that Gullu's analysis has been helped you in applying how to use the physical properties and to select the perfect size of the member, then hit the like button, press the bell icon and subscribe to my channel and share it with your colleagues.